Hi everyone, and welcome to this video, Research Design, Correlational Designs. In this video, we'll answer some questions such as what is a correlational research design? What are the strengths and limitations of correlational research designs? How to identify correlational research designs? What are correlation coefficients? What are scatter plots? Beware of illusory correlations. Why do we fall prey to illusory correlations? How can we minimize the risk of falling into illusory correlations? And then we'll conclude with a review. So what is a correlational research design? A correlational design is the examination of the extent to which two variables are related to each other. What are the strengths and limitations of correlational research designs? Well, the strengths are if and to what extent variables are related. So we can see, maybe we want to understand, is depression related to students' exam scores, right? So then we would give students measures of depression, and then at the end of the semester, we could look at their exam scores and see, is there a relationship there between exam score performance and level of depression. The other strength is that correlational research designs can help us with prediction. Again, not perfect, but we can make decent predictions based on certain test scores for some people, for example. Like scores on the MMPI-3 suicidal ideation scale is predictive of people having suicidal ideation and or being at risk for suicide. Limitations. With correlational design, again, we cannot infer causation from these results. And this is why, and this is when we need to really be thinking about the scientific thinking principle, one of the 6 that we've been discussing in this course, which is beware correlation versus causation fallacy. Just because things are related does not mean one caused the other. Why? There are 3 possibilities when we look at relationships between variables: height and age, calorie consumption and IQ, right? Like we could see if there's correlations between various things, see if they're related. We can't infer causation because there are 3 competing explanations. 1, A could cause B. So for example, let's say we want to know, let's say we find a relationship between ice cream sales and crime. And well, in this example, are we going to say that ice cream sales caused crime or crime caused ice cream sales, right? So in some situations, we can't determine which one caused which. And in this example of ice cream sales and crime, this is an example of the 3rd variable problem, because if we find a relationship between ice cream sales, as ice cream sales go up, crime goes up, and as ice cream sales decrease, crime decreases, maybe there's a 3rd option, a 3rd variable that's causing both A and B. This is known as the 3rd variable problem. And what we tend to see with our example of increased ice cream sales and increased crime and vice versa, it may be related to the weather, to heat. As the heat rises, people tend to become more aggressive. Maybe they're outside more. So if we look at crime as far as physical aggression, right? And also when it's nice out, people tend to eat more ice cream. And when it's not as hot out, people tend to eat less ice cream, right? So we need to be aware of, just because things are related does not mean that one caused the other. But A could have caused B, B could have caused C, or a 3rd variable. So how do we identify correlational research designs? Well, if someone's talking in the news, hopefully when they're reporting on a study or when you're reading about a study, that they're using these words accurately. But there are 4 pretty good indicators, words that signify that a correlational design study was utilized, such as words like associated or association, or, X was related to Y, or there's a relationship between X and Y, or X and Y are linked, or X and Y went together. These words tend to signify that a correlational design was used, because all they refer to is that there's some sort of relationship. They're not implying causation. And again, sometimes, be on the lookout for that. You might have to look at a study further. You may have to kind of ask more questions, because sometimes people will talk about a correlational study or correlational findings as causal. And they'll say, they might say X caused Y, when you really look, it's like, no, this is a correlational design. We need to be cautious about that. So look for these words, though, and they suggest an association. What are correlation coefficients? Correlation coefficients are a family, they're various statistics that tell us the degree to which two variables are related. Okay? So correlation coefficients can be positive. They can, like you see here, positive 0.5. Sometimes they usually won't have the plus sign on there, but they can be positive. They can be negative, like we see here, negative 0.7. They should have a negative sign if it's a negative correlation, or a zero correlation. Things rarely correlate at zero. That's a long statistical conversation. But basically, correlation coefficients can be positive and negative. They range in value from -1 to +1. Again, we rarely see this, and if you did see this a correlation this high, it could raise some concerns. But a correlation of 1 is a perfect correlation. Those two things perfectly went together. And the same thing with a negative correlation. And I'm going to show you a scatter plot to show how this looks on a graph to kind of give you a better idea. So what are scatter plots? Scatter plots are just a visual representation of the data of various relationships. So it's a plot of scores of two variables. And what we can see here is we have 3 examples of scatter plots that suggest correlations or relationships between two variables. On the left-hand side here, we have 2 gentlemen who look like they're enjoying drinks of some kind. And what you can see on the vertical axis are scores, student scores, psychology exam scores. Okay, and they range from like 50 to 95 there. And then on the horizontal axis, you can see the number of beers consumed, either before the exam or the night before. And what we can see here is a negative correlation. And this one looks decently high. So let's, for the sake of argument, I'm just making this number up, but a strong association in negative direction. Let's say it's negative 0.7. What this scatter plot shows, and what a correlation of negative 0.7 would suggest, that as psychology exam scores increase, the number of beers students drank the night before exam decreased, which you can see by the downward sloping line on the left-hand side here. So as psychology exam scores increase, students who did better on exam scores were less likely or drank fewer beers the night before. So this is what we call an inverse or a negative relationship. We could also say this the other way. As the number of beers consumed the night before a psychology exam increased, the score on the psychology exam decreased. Okay? Again, negative association, negative relationship, inverse correlation, inverse relationship. As one goes up, the other goes down. Okay? That is what the scatter plot suggests for that there's a pretty good relationship there. A negative correlation on the left-hand side. In the middle, this would be our like zero correlation or like no relationship. So again, let's say some researchers asked students to report their shoe size and then correlated that with the psychology exam scores and found that there's no relationship. Shoe size is unrelated to psychology exam score. Psychology exam score is unrelated to shoe size. That's this picture in the middle here of the scatter plot. The final picture on the right is a scatter plot showing each dot, again, is a student's score, and in this case, also percent of class attendance. So on the vertical line, we have the psychology exam scores. On the horizontal line, we have the percent of classes attended. And what you can see here is that there is a positive relationship. There is a positive association between psychology exam scores and percent of class attended. So let's say that this is a positive correlation with a correlation coefficient of 0.8, for example. That'd be really high. What this scatter plot suggests and what a correlation coefficient of 0.8 would suggest, that as psychology exam scores increased, so did the percent of classes attended. And we could say the opposite. As psychology exam scores decreased, so did the percent of classes attended. Or we could say there's a relationship between the percentage of classes attended and psychology exam scores, right? We're clearly demonstrating that there is a link. Now, again, we're not saying one caused the other, because, maybe students are studying more who also go to more classes and those kind of things. But what we could say is there's an association. This third graph is a positive association, demonstrates a positive relationship. And the empirical literature, just so you know, does suggest this is a consistent finding. I know that this is just a graph as an example, but we do know the more classes you attend, the higher grades tend to be. Again, probably not causal because there could be other factors, but it's helpful. Come to class. Beware of illusory correlations, illusions, statistical illusions. So an illusory correlation is a perception of a statistical association where none exists. I love this graph, this table that I borrowed from your textbook authors. And what you can see here is this is a table plotting psychiatric hospital admittance and the presence of a full moon. And a lot of times we tend to form illusory correlations, misperceptions. We misperceive a statistical relationship, that things go together. And in this example, a lot of times people, especially in public safety, healthcare professions, tend to believe and fall for this illusory correlation more than people who may not work in those fields. What some people believe is what's called the lunar effect. That is, that the presence of a full moon is related to psychiatric hospital admittance. A lot of people are only paying attention to cell A of the table in red. They're not paying attention to the other tables. So we tend to remember the hits and forget the misses. We tend to remember the times when people were admitted under a full moon to the psychiatric hospital, but we tend to forget all the times there was a full moon and no psychiatric hospital admittance. We tend to not pay attention to no full moon and psychiatric hospital admittance, and we tend to not pay attention to no full moon and no psychiatric hospital admittance. Okay? Why do we fall for these illusory correlations? Well, we tend to fall prey to them for probably at least two reasons. One of them is selective attention. Again, we focus on the upper left-hand cell of the fourfold table. I'm going to go back to that slide. We tend to focus on cell A and not the other cells. We also tend to pay too much attention to memorable events while not paying enough attention to non-memorable events. Oh yeah, we already have the idea in our head that these things happen or the psychiatric hospital admittance happens, so we tend to pay more attention to it. Full moons are attention grabbing. They're unusual. They're rare, and it's like when we have them, they tend to be reported by the news, and people tend to engage in a confirmation bias. They're looking for psychiatric hospital admittance. They're looking for things to happen, but they're not looking for things to happen when there's no full moon, even though those things do happen, but they forget them. So how can we minimize the risk to falling into illusory correlations? One, by tracking the data. So with our fourfold table there, we could track. And you could do this at work if you work in a healthcare or public safety field, and you wanted to somehow see if this is an illusion. Track all the disconfirming instances as well as, some of these other ones, but really pay attention to the disconfirming instances. When were people not admitted to the hospital? When was there not a full moon and people were admitted, right? And then you could compare the rates within the cells of the fourfold table. And the phenomena of illusory correlation explains why we can't rely on our subjective impressions to tell us whether two variables are associated. Sometimes when we perceive the association of variables, sometimes it's just an illusion. But using correlational research designs can help us determine if a relationship exists. And what we have consistently found is that there is no relationship between the full moon and various phenomena like psychiatric hospital admittance, suicide, weather phenomena, those kind of things. So in review, correlational designs are the examination of the extent to which two variables are related. The strengths of a correlational research design are that they help us determine if and to what extent variables are related, and they help us actually with prediction and statistical models. Limitations are we can't infer causation, and maybe there's a third variable causing both A and B. Indicators of a correlational design are when people use words such as associated, related, relationship, linked together. A correlation coefficient is a statistic showing the relationship and the direction of the relationship. So again, a positive means things are moving together, both going up as one variable increases, the other variable increases, or decrease as one variable decreases, the other one decreases. And a negative correlation or an inverse correlation, as one variable increases, the other one goes down, vice versa. Okay. Scatter plots are a visual representation of data points, and then we can draw a line through there to see if there's a relationship. Illusory correlations are the misperception of a statistical relationship in its absence. And then minimizing the risk for illusory correlation, track all the disconfirming cases and compare them to all four cells. Thank you for watching. Send me an email if you have questions or comments. Thank you.